Hi everyone, we are going to take our class notes on 8-4 today. Today is April 7th, and today we in 8-4 will be adding and subtracting radical expressions. Different than multiplying, which we've been doing. So adding and subtracting, they have to be like. Very similar to other things, so this is why I'm showing what you see about below. In order to add and subtract radicals, the index and the radicand have to be the same. That's when we can call it like, when you have the same radicand and the same root. So these are both square roots and they're both square root of 6. So because of that, we can consider these like, and that's why we can put these together. So it's very similar to like terms in algebra, right? Seeing, just replacing all the root 6's with x. 5x plus 7x, yes, we can combine those because they are like. With addition, we have to have like terms in order to add. What do we add? We add the coefficients and we keep what's like. So we just add the 5 and the 7. We keep what's like. We keep the like root, which is 6. Same index, same radicand. That is the only way you can add. So if they're not the same index and same radicand, you have to simplify and try to get there. And that's what we're going to do in our 4 examples now. So I'm going to have my power sheet and my calculator. And I'm going to work to simplify these because I look at these are not like, and I'm being asked to add these together. So I need to find the perfect square because this is square roots that goes into 12. So I'm going to keep the 5 outside, and I'm going to break up 12 into 4 times 3 because that's the biggest perfect square that goes into it. And then I'm going to keep that y. So then I have a 6, and I'm going to break up 75 into 25 times 3 and the y. The biggest perfect square that goes into 75 is 25. If you're not sure of that, power sheet, work your way to figure that out. Perfects come out, not perfects stay in. 4 is perfect. It comes out. When it comes out as something different. And what do we do with the 5? And the 2 that we're going to bring out, the square root of 4 is 2. We have to multiply. We don't see an addition sign there. That means multiplication's going on here. So we're going to do 5 times 2. Which is 10. 3 and the y need to stay in jail. They're not perfect. 25 is perfect. It comes out as 5. The 5 and the 6 we multiply, and we keep the 3 and the y. Not perfect, not perfect. Now are these like? Yes, I see a root 3y and a root 3y. So I can add the 10 and the 30 to get 40 root 3y. Final answer. 40 sits outside being multiplied. If you wanted to put a multiplication dot there so it doesn't look like the index, you can do that. Okay, 4th roots. So power sheet for 4th roots because we're less familiar with that. Finding the biggest perfect that goes into 32 on our perfect fourths. So it's going to be 16. I'm going to break that up, keeping the negative 2 outside, the 4th root, and I'm going to write it as 16 times 2. Minus keeping the 7 on the outside and working with 162. So seeing if 81 goes into 162. And it does. 81 times 2. So I'm going to rewrite this as 81 times 2. 16 comes out, perfect fourth. 16 comes out as, try to get my pencil here, as a 2. And 81 will come out as a 3. So when this comes out as a 2, we multiply it with the negative 2, get a negative 4 times the 4th root of 2, minus 81 comes out as 3. We multiply it with the negative 7, so we get a negative 21 root 2. 2 is not perfect, it's staying in. 81 was perfect, it came out. 2 is not perfect, stays in. 16 perfect comes out as something different. Are these like? Well, let's not forget our indexes. That's very common that students will do that. Are these like? Same index, same radicand. Yes, I can combine the like piece. I can combine the coefficients out front and keep the like piece. So negative 4 and negative 21 is a negative 25. Keep the like root, which is the 4th root of 2. Done. A cube root, practicing with cube roots. Well, I see more x's underneath than the index outside, so I'm going to break that up. 3 doesn't go into 4 evenly, so I'm going to break it up as to x cubed times x. And then 3 doesn't go into 7 evenly, so I'm going to break that up into perfect and not perfect, which will be y to the 6th and y to the 1st. Right, so this is perfect, this will come out, this is perfect, this will come out, that, and that will stay in. Minus the cube root, I'm going to work with 64. Cube root of 64, under cube, 64 is perfect, that will come out as a 4. And so I'm going to actually erase and slide this over. So 64 is perfect, it comes out. And then I'm going to have my cube root. X is not perfect and y is not perfect, so that's going to stay xy. And I could do that in the next step when I take out what's perfect over here. But I recognized it, so I'm taking that piece out. X cubed is perfect, divide, you bring out an x. Y to the 6 is perfect, divide, you bring out a y squared. Keep the cube root, what stays under? That came out, we have an xy that stays under. Minus 4 and the cube root of xy. Are these like? Yes, I see cube roots and I see the same radicand. But what's outside is not like, so how do we show that? We just show xy squared minus 4 times our cube root of xy. Final answer. We can't put those together like we did here because those were like, and 10 and 30 were like. And our last one, we are being asked to add, so we're still adding radicals here. What stands out to me is their square root. So I see 36 is perfect, but I see 108 is not. So I'm going to work to say that this is the square root of, I'm going to simplify 32, 16 times 2, and I'm going to take the square root of 36, which is 6. So that's out of the jail. Here, not perfect. 27's not perfect, so I'm going to rewrite this one, which I did this the other day as well, like this, and then try to reduce that. So if we're using our calculators, I'm just going to reduce this on my calculator. And I'm going to do 27 over 108, and I'm going to see that that reduces to 1/4. So I'm going to work sideways. I'm going to work this way. And so I get 2, and then the root 16 will come out as 4. So I get 8 outside. 8 root 2 over 6. So I can do some reducing with this. Plus 2, and now I have root 1 over root 4 when I divide these. So that means these are both divisible by 27. And so 1 is perfect, that will come out as a 1, and 4 is perfect, that will come out as 2. And I'm going to reduce this over here. So I'm going to get 4 root 2 over 3 plus 2 over 2, right? 2 times 1 is 2, and then that's 2. So that becomes a 1. And so if I want to write this as 1 fraction, I'm actually going to write the 1 as 3 over 3. So then I could say my final answer is 4 root 2 plus 3 over 3. Final answer. Those are not like radicals, so we can't add the 4 and the 3. Please don't add the 4 and the 3. They are not like. Okay, those are our 4 examples for today. Have a great day, everyone. If you need one-on-one help, please ask. We can maybe try to figure out a time to Zoom. Thank you. Bye, guys.